Today we're traveling again to St. Petersburg to start our fifth lecture, which will be held by Dr. Yuriy Zhukovskiy on digital competences as a basic requirement for modern mining and energy. As it can be seen from the topic, it will open the second thematic area devoted to the digitalization in mining. Today, it is our honor to greet Associate Professor Dr. Yuriy Zhukovskiy, who is the Director of Research Center for Digital Technologies at St. Petersburg Mining University. His scientific interests lie in the field of diagnostics and estimation systems of electromechanical equipment and residual life based on Internet of Things technologies. In his research, he focuses on scientifically grounded methods of energy saving in the enterprises of mineral and raw material complexes. This lecture will give you insights into digital competencies and their role in the mining industry. What is actually meant under digital transformation? How will the transformation of the mining industry influence the achievement of the Sustainable Development Goals? Which level of knowledge is important for the digital transformation of the enterprise? We're looking forward to discuss these and other questions now. Please join me by warmly welcoming Dr. Yuriy Zhukovskiy.
Good morning, dear participants. I am Yuriy. I am Director of Scientific Center for Digital Technology of the St. Petersburg Mining University. Our lecture focuses on the topic of digital competence as a basis requirement for modern mining and energy. I would like to say that I wanted to give up a lecture from the laboratory from St. Petersburg Mining University, but unexpectedly the government of the Russian Federation decided to make the first 10 days of May holidays. And I am giving a lecture from home, but I think this did not stop us from taking about very important things about digital transformation and role of competence in digital transformation. So Anastasia say some words about me and some we discuss in our lecture 5 keys area. First of all, global energy challenges, key trends in energy sector, priorities for digital transformation, the role of digital competences and integration of competence. So we know that the world is constantly growing. This growth leads to high energy consumption. Last 150 years, the main resources, primary energy has changed several times. It was wood, the coal, but now we live at the area of oil. A lot of forecasts show that the gas will be next. It is gas that is called bridge fuel, symbolizing that is the energy that can help the world to move to some other energy. But at the moment, there is no common understanding of what energy it will be. The world can swing towards nuclear power or thermonuclear fusion or renewable energy sources. Also, the world may move to more difficult to extract hydrocarbon deposits. There are many directions. We cannot indicate which of them will be a leader. And now we live in the area of oil. We expect that from 2040, it will be area of gas. So if we look at electricity, we will see that change will occur earlier. If we look at the capacity for 2020, we will see that coal is still the leader and gas will the leader around 2026. But it just for a decade. By 2035, solar energy will become the leader in installed capacity, but we cannot compare 1 megawatt of gas power and 1 megawatt of solar power. The maximum gas capacity factor will be determined by the operator. In solar energy, this coefficient is determined by the presence or absence of the sun. But as we see, this change are taking place and part of the world pays attention to renewable energy. Another part of the world is still building up gas capacity or coal capacity or atomic capacity. Thus, we understand that the demand of the modern world for every energy is very great and it will grow from year to year. Uh, we connect electricity, we connect energy consumption with the amount of services we receive. What is the quality of life that must grow steadily? It means that we must consume more services per unit of time. We consume more and we think that the standard of living is increasing. This model leads to the fact that all our action that we perform, we connect with the consumption of electricity. But electricity is secondary resources and primary resources is needed for it. You can see that everything we do is related to kilowatt hour, and even if the devices become better and more efficient, the number of devices is only growing. If you look at the last 10 years, you can understand that energy consumption is very strongly associated with processes that people generated. If we look at consumption per person, we will two parts of the world. Those who try to increase the consumption in order to make their economy more developed, those who try to optimize, invest in energy saving technologies, reduce consumption. It is a division of the world. Over the past 10 years, the number of people who live in cities has also increased, and more countries want to move a post-industrial economy. We live in the area of Internet of Things. Since 2011, according to Cisco, the number of things on the internet is greater than the number of people. We must understand that 21 billion things communicate on internet without people. The most immodest prediction relates to 200 billion Internet of Things. Thus, a tenfold difference in the assessment indicates that no one sees the real picture. All these devices require energy consumption, not only for charging, but also for information transfer. Each of devices wants to send, receive, store, or process information. The world spends a significant amount of energy for it. One of informational technologies is blockchain, which implies the use distributed ledger to create one of the cryptocurrency and the energy chart that says that technology consume energy like Belgium or Netherlands. Could anyone have guessed 4 years ago the second Netherlands in terms of electricity consumption will appear in the world? It didn't not appear because of new people and processes with emerging technology related to banking and cryptocurrency. This technology results in consumption of 100 terawatt hour per year. This does not seem to be very large. Russia reduced 1070 terawatt hour per year, yes, but it is in third place in terms of electricity generation. Such technological development increase consumption. As a result, increase the burden on need to create this energy in the first place. If we look at forecast for the next 20 years, we will see that consumption is really growing, and the number of countries who reduce consumption correlate with swarms of other countries who try to increase it by the next 20 years. You can see that the biggest growth is consumption is concentrated on the continent we are living. We are living in Russia, in Europe, and uh, mm, we understand that consumption will grow around us. Our energy and money need to change to reflect global changes in the world. We see that most of energy and materials that the world are especially our countries wants to receive, they will not achieve it on other own. The main part of the support will fall on Russia. Do do we need to prepare now? Yes, we need. We start thinking about it. We can conclude that population growth, increased consumption, scientific and technological progresses, urbanization, environmental and climate change, economic crisis, and the decentralization of the world are global challenges that we pay a lot of attention. Each of these challenges requires a separate answer to those changes that we need, and these changes take place. Change change has have begun to happen in 2017. A 3D concept in the energy sector was formed in the European Union, which implied three key trends. Uh, First of all, it's decentralization. We are moving away from large generation to end use generation. And this generation is really getting bigger. Along with this generation, it is necessary to thread regulation and management differently. There is trend towards decarbonization, a trend towards reduce the environment impact of fuel and energy complex. This trend formed all over the world under influence of the Sustainable Development Goals, makes itself seriously felt. We see more and more countries, companies that are increasingly turning to decarbonization in the energy sector and trying to switch to source with lower carbon emission. Well, digitalization and establishing trend that permeates almost all process in the energy sector. This trend, which links the previous two, that is, we cannot achieve significant processes in decentralization, in decarbonization, without digitalization. We at the Mining University in St. Petersburg note another two trends. First of all, this increase information technology depends of production, transport, and use of various type of energy on each other. We can become more efficient if we don't see the processes and don't understand what is happening outside of our field of activity. If we have changed in electricity, in the electric power industry, then it's important for us to understand what is happening with the primary energy from which we draw electrical energy. The trend is to reduce consumption not only of energy but also of all type of resources and materials, reduce the amount of waste and increase the environmental in recycling. Indeed, more and more people business rely on completely different growth points that they were 10 years ago, and many find growth points not in increasing consumption, but on the contrary, in its decline, in its involvement in waste recycling. This is an established trend that is changing the face of the energy sector as a whole. Under influence of these trends, and understanding has begun forming that digital transformation is necessary as a linking part of all these key changes that we are seeing today in the energy sector. But for most part, when people say what digitalization is, they tend to believe that is some kind of technical transformation. That is a transformation when we change something analog to something digital. Uh, or when we translate some information from analog to digital, but this is only the first stage of one of the levels of digital transformation. What do we mean by digital transformation? Yes, this is a technical transformation, of course, it is a starting point, but it is also a transformation of business processes without which movement is unthinkable. If you have changed, you have obtained information, new knowledge is extracted from this information. New knowledge generates change in the business processes. This is transformation in the regulation of not only a separate area processes, but in the regulation of an entire industry. This transformation in the structure, because under the influence of the opportunities and technologies that we have on the basis of the information that we generate, collect on the basis of that knowledge, we change the structure. Well, as a transformation in management, this management that we have today should be completely different. Again, when we turn to our decentralization, for example, when in the Russian Federation, in the entire unified energy system, which covers 9 time zones, there are a little more 850 power stations. And when you manage a little less than 1,000 stations, this is one approach. But when there are 2, maybe 5, maybe 10 million stations, this is a completely different approach in managing the stations. This management can no longer be carried out by only one person on the basis of their knowledge and competences. It is managed, they must be carried out together with information that will be imbibed in the processes, in the regulation. This is a kind end-to-end transformation that we talking about at 5 levels. It is this transformation that is necessary for the key change and acquisition for those properties that we laid down in the concept of Industry 4.0. And these properties are acquired by both energy facilities and mining facilities. According to the key qualities of Industry 4.0, which are obtained on the basis of 5 levels of transformation, relate to the speed of the processes themselves, their transformation, the speed of bringing new products to market, flexibility in terms of supply, communication with the client, adjustment to the client, flexibility in terms of change to responsivities to change that occur in the external market. And uh, this is efficiency in which energy, environment, and economic efficiency are invested, and we do not consider them separately. They act harmoniously, they together as a single quality accompany the work of enterprises. And the security that we invest in the security of supply and cybersecurity and the security of our processes that we manage through the digital transformation. It is these key qualities that we lay down in the change or the need to change them that we want to achieve. So another key challenge is the coronavirus, which greatly influences the creation of key properties. Flexibility is necessary in terms of rebuilding processes. If we look at this slide, we will see that a very large drop down in consumption was received by countries where most of the economy is built on services. For example, in Russia, quarantine restriction did not affect very much, but in Italy, Spain, the United Kingdom, it affected significantly. You can see from this graph that the adjustment and changes that were necessary based on information were not carried out, and most energy companies were not ready for such changes. And along with them, primary sources were not ready. At the end of the year, the world began to consume less uh, coal, oil, gas, atomic energy, and the demand for electricity energy decrease. The only positive thing left is only renewable energy source. Well, a plus can be called a reduction in carbon dioxide emissions. The huge amount of investments that the energy industry has not received will hit very hard in the coming years. Perhaps some of the industries today will not receive such investments they would like to receive. The flexibility of processes, the speed of their restructuring, and the security of processes become very important. We made an analysis of the current trends that are currently present in the energy sector. We compare it with trends with the achievement of the sustainable development goals. I think that is in many lectures, the concept of sustainable development goals has been discussed during development in economic efficiency, social policy, and ecological uh, needs to be implemented today. Most of the sustainable development goals are related to the trends that we see at the moment in the energy sector and in the mining sector. When I talk about the energy sector, I'm talking about the coal energy, gas energy, electric power, and oil general, because in Russia, it's one ministry. After compare the sustainable development goals with current trends, we analyzed the risk that took place in the energy sector in 2020. One of the leaders in terms of risk was emergencies associated with the spread of epidemic of various viruses and so on. However, the shortage of human resources, the deterioration of the quality of the characteristic of hydrocarbons, and the growth of hard to recover reserves are also among the key risks for the entire energy sector today. I would like to say that interest here was not to analyze one industry, but to see what is happening in general with the energy sector. So, as a result of our research, we have formed three scenarios. Sorry, three scenarios based on the approach that we have good, bad, and moderate scenarios. These three scenarios were presented to the experts in order to compare them with those key trends from the previous slide. There are a bad scenario called stay home, the moderate scenario, stay alone, and the good scenario, stay effective. So you can see the description of this scenario on this slide. We analyze the response. Okay, we analyze the response of the of more than 100 experts from energy sector. After that, we conducted factor analysis and decided to coordinate several family representations. We became interested in the question of which of our direction will be common for all three scenarios. We have identified what needs to be developed regardless of scenario. So, second, yes, okay. After analyzing this, we got a set of generalized components that describe most of the data that we collect. We have assigned our names of these components, symbolizing which of the sector needs to be developed based on these components. The most important key area was the need to digitize the infrastructure. As you can see, it's very red on this slide. Uh, and ensure the reliability of its energy infrastructure. The personal trend is also one of the priorities. The name of our components, you see on this slide, according looks like this. In fact, they describe the change that need to be made in the energy sector for sustainable development. These are the movements that need to be done in one manner, developing all the industries together. The 9 key programs should be developed in the energy sector in order to meet the sustainable development goals for the harmonious development of this complex, both from the social sphere and from the environment. Digital technologies play an important role in this development. When we invest in digital technology, it means that we're investing in achieving the sustainable development goals. The Russian Federation last year, despite the pandemic, released its report to the United Nations. There, the role of digital technologies in achieving sustainable development goals was very strongly emphasized. Mining companies and energy companies that invest in digital technologies and achieve the goal have been represented there. When we talk about digital technologies, for the most part in the Russian Federation, we divided them into several key blocks. I will highlight only 6. It's a big data, predictive analytics, artificial intelligence, industry 4.0, virtual virtual reality, distributed ledger, industrial internet of things. But when we get to a single industry, this set of technology begins to divide into many. And this technology is starting to divide into many, but we understand that all these technologies live of information and live of energy, which plays a very powerful role for the mining industry. Why? Because any device that transmits stores and process information is made of the materials that we get from the earth. As mentioned earlier, more electricity is currently generated from gas and coal mining, as most of the devices on which the energy transition is based are also made from materials that we get from the earth. There is a serious threat that the mining and processing industry, due to its efficiency, may become a constant for digital transformation, not only in individual industries, but in the world as a whole. Uh, since digital transformation concerns not only energy and minerals resources, but also concerns the economic and social sphere, it is important to understand that uh, if we do not make the mining industry efficient, then we will not make digital transformation efficient in January. Okay. Turning to one of the studies of our colleagues from the University of Aachen in Germany, who conducted research on what digital technologies have developed in mining industry in recent years. We see that indeed the progenitor of all digital technologies of today is automation as the basis of Industry 3.0. It also the foundation for Industry 4.0, because the transition to Industry 4.0 is not possible without going through Industry 3.0. Indeed, only after automation we are seeing the emergence of artificial intelligence, machine learning, and Internet of Things. These are technologies that are related to each other, but very strongly related to the areas of automation. If we look at the right heat map, which tells us where and what key processes of value creation, which in digital technologies were used, we can see that automation is applicable in almost areas, in all key processes of value creation, data creation in real time. It can also be noted that the digital technologies are practically not used for the educational sphere. And this is an essential fact that we will pay attention to. When, okay, yes, when we talk about energy supply, the range of technologies here is also quite wide. We conducted this research at the Mining University. We tried to match technology with the effects we want to get, because wherever we talk about the application of technology and innovation, we want to see the effects. In our study, we really tried to compare which digital technologies for energy supply and the electric power industry will lead to certain effects. Key technology are not yet fully available today, which means that it's necessary to invest in them. Also, most technologies are not only internal processes technologies for enterprises, there are end-to-end technologies that can be applied outside in electric power industry. The change that are currently related to the electric power industry are compared with the smart grid. This technology originated in 2003, which links the power industry into a single complex. The smart grid is riddled with a map from International Energy Commission that shows how from the lowest level, you can see it's down the level, we connect to the highest level on the markets. The four key technologies that permit everything are telecommunication, security, energy management, and power quality. Naturally, all challenges revolve around energy saving. This map is inherent only for the electric power industry. You need to understand, if you make only the electric power industry smart, but at the same time level leave everything stupid in the chain, starting from primary energy resources, ending with transportation of related resources, gas, heat, oil, and other energies, we will not achieve the necessary effects that we want. It is necessary to make unified energy system, uh, which will be made on the basis of information, where digital transformation plays a very important role. One of the key factors that needs to be developed in any set of thermal constants in the energy infrastructure, it is a point where you need to invest, and this is due to the fact that the energy infrastructure itself, which is the source of information infrastructure, can become a barrier of digital transformation. The mission of the energy infrastructure to accurately offer everything that the consumer wants to cover is not entirely correct. We need to integrate more into the consumer, work more with the consumer, teach the consumer to manage our infrastructure efficiently together with us. We are all connected in single processes, and information give us insight into the connection. And since energy infrastructure is one of the most undivided areas, digital investments are the most attractive. We emphasize it in our research, trying to assess how the infrastructure today compares with the properties that we want to get: reliability, cost of ownership, availability, observability, assigned rate, service time, bandwidth, environmental safety, evolution was carried out to date, as well as the scenarios that were offered. And we saw that even in the best scenario in the Russian Federation, we will not see the achievement what we wanted. By technology, digital and information technology had the greatest impact of energy infrastructure and had one of the lowest technological change rates. That is, we will get the smallest investments and at the same time the greatest effect from these two areas. By investing in them, we transform the energy infrastructure and give them new properties in the concept of Industry 4.0. After doing this research, we tried to research that dealt with personal. It is important to note that digital transformation is based on people. It is not done by artificial intelligence. All decision and knowledge are still based on knowledge of people. So the completeness of today's engineers is very important. We conducted a study in 2017, 2019 of those people who come to us to improve their qualifications about their level of knowledge in the field of digital technologies. Uh, these were people from the economy, automation, mechanical, and energy. Our assessment of the average statistical level of 5 points showed that none of the representatives of these professionals research 2.5 points. It is impossible for an enterprise to carry out digital transformation with this level of knowledge. These are not the people who can change the processes and approach to management. People who change are universal soldiers or talents who combine a number of professions. And the diagram shows that we need a person who can be both an economist and be an agent in automation, mechanicals, and energy, also has serious skills in IT technology. And then we get transformer, a person who transforms everything around him. In 2018, an idea appeared at the St. Petersburg Mining University to create a digital technology center, which will be focused on education engineers who will have greater integration of various competences and specialists, because using, for example, of energy today, we are investing in them as seriously physical and mathematic apparatus of material science, electrical engineering science requirement of today from enterprise that want to get our power engineers is not just a clean power engineer, but a person who must be, in a sense, a lawyer. He must know the information, telecommunication infrastructure, understand data transmission networks, be able to build them, know the second language, English, maybe, yes. But this all day has passed the day after tomorrow. Already modern enterprises that are already transforming want to the power engineer to know programming very well, to be able to build neural networks, write machine learning algorithms, process big data. It is difficult for university to build up such a volume of competence in 4-5 years, and this is practically unrealistic. Relying on human and intellectual capital and integrations with companies, and they are undergoing digital transformation, who create digital technologies for other digital transformation companies. We have outlined the achievement of these goals that we want to achieve in terms of transforming approach in education for digital transformation. That is to obtain new specialists with new knowledge that will be integrated in several directions. And for this, sorry, just okay. And for this, such an infrastructure was created as a Center for Digital Technologies, which includes several companies today. There are 9 laboratories, some of them are educational, some of scientific, which use all the key digital technology for electric power industry, for mining and oil and gas industries. We do uh, we do not act and work alone. There is a lot of support from the Competence Center and aspect of UNESCO, which is a very strong coordinator in the area that develops our interactions. And there is also the Russian-German raw materials dialogue, in which political and scientific views meet annually within working groups. There is an international certification system for mining engineers, which is kind of a consortium that grows in terms of uniform changes that are necessary not only in the mining industry, but in the mineral resource complex and the energy sectors. In the Russian Federation, most companies send people for advanced training, not to equipment manufacturers, but to universities. Many company specialists go through the basics of digital transformation with us, studying digital technologies that can later be useful in enterprises for sustainable development. And we also pay attention to use of digital tools for teaching those young people who will come to us in few years, since these people can no longer imagine their present day without tablets, phones, digital assistants. Naturally, the university should focus on these people and understand that is not exactly online education, but digital technologies and education, which allow young minds to master technological processes faster and more efficiently. Because they will have to master much more than we master. That is why we launch a community called We What. So this community is kind of call for the integration of competences. This brings together specialists among student and PhD from different fields. These experts come together to form teams. Teams as a foundation of digital transformation. One person will not to do as much as a team does. It is important to teach these people to work in team, learn and understand each other. It is such a system when everyone wins, when achieve common goals, that allows a person practically in the ambience of a teacher to acquire other competences from another specialty. For example, uh, when we connect an ecologist with the energy specialist, with a miner, with a specialist from oil and gas sector, from IT technologies, we get those opportunities when they all think about sustainable development, and this allows them to learn new things faster and more efficiently. This project allows us to achieve new results, and this was noted at various conferences, as well as the Ministry of Energy of the Russian Federation and Ministry of Education, as you see. Uh, in conclusion, I would like to say that the challenges that we have outlined in competence are also taking place in the energy industry, because the collaboration that happens with people, exactly the same collaboration based on digital platforms, is taking place in industry, because not only the enterprise is being transformed, but the whole industry. It is It is the industry that gains greater efficiency and greater opportunities in order to get on the tracks of sustainable development. It is digital transformation that is based on digital competences that will allow the entire energy sector to become more efficient, and mining sector too. This is very important because today we must invest and develop in integration of competence in order to get real collaboration between different specialists. It's very important today. On this, I perhaps will stop.